All right, hello BNS 210. Today we are going to talk about One Way ANOVAs. Normally, I have this slide up here because normally I do a One Way ANOVA lab where we do a thing with M&Ms to kind of show what this is like, but we're not going to do that. Instead, I'm just going to give you a brief overview, and then I do have a worksheet that's going to be with this. So I am going to be posting that worksheet up for you guys to work on. The worksheet, just so you guys are aware, is going to be just for completion. Let's see, I'm going to post it up today with this video, and let's make that worksheet due. Let's make it due Wednesday by midnight. Okay, get it to me. You could email it to me. You could print it out. You could write on it, and you could take cell phone pictures of it and email it to me. You can scan it and email it to me. You can, however you want to get it to me is fine. And we'll make that worksheet due. It's going to be a Word doc, so you could type on it. You will need to use SPSS for the worksheet, and I'm happy to answer questions. We'll go over it. We can go over it. Do you guys want to maybe do like synchronized, maybe we should do synchronized lectures every Friday. Maybe that would be good. And we can meet on Friday and talk about the worksheet, and we can go over it. I will be moving forward in these lectures as we go through the week. Okay, so One Way ANOVAs. So what we've talked about so far was the t-test. The t-test is only when you're comparing two means. That's all you're doing with the t-test. So you can only do it on single factor two-level designs. That's the only time you could use a t-test. So now we're going to talk about the one-way ANOVA. As we get into ANOVAs, and ANOVA means analysis of variance. And I haven't talked about the mechanics of the ANOVA just yet. I wanted to practice with it a little bit first, and then I'm going to start getting into what an ANOVA means and what we're actually doing with the ANOVA. An ANOVA is an F test, not a T test, but I'll get into the mechanics of that later on. For now, I just want to talk about when we use a one-way ANOVA, why we use a one-way ANOVA. It's called one-way because we're dealing with one independent variable, one factor. When we get into factorial designs and we start talking about two-way ANOVAs and three-way ANOVAs, that means we have two factors, three factors, that sort of thing. So this is a one-way because we only have one factor. So we're doing this when we have single-factor, multi-level designs. So you might be asking yourself, well, why can't we do a t-test? We could just do multiple t-tests. Well, every time we do a test, we're taking a 5% risk of committing a type 1 error. So remember when we talked about what the p-value means, what all that means with the type 1 error. So whenever we do a test, every test we do, we're making a 5% risk of a type 1 error. So the reason why when we have a multi-level design, why we shouldn't do multiple t-tests is because every test we do, let's say we have three factors, and you're comparing this one to this one, and then this one to this one, and then this one to this one. That's 1, 2, 3 tests. So what we're doing is each one of those tests, we're doing a 5% risk of a type 1 error. So what we end up doing is 5% plus 5% plus 5%. We end up actually taking a 15% risk that we're going to commit a type 1 error. So it inflates our type 1 error rate whenever we do multiple tests. So here I'm going to give you an example using this simple design. So here we want to know if playing the PlayStation and how it affects reaction time. Reaction time has been our infamous dependent variable here throughout the semester, so we'll just stick with that. So we want to see if people who play PlayStation more, if they have a decrease in reaction time. So I'm going to do a between subjects design. I have 5 different levels here, and I'm going to find 25 subjects, and I'm going to put 5 of them in each of these groups. This is between subject design, and I'm doing this randomly. Okay, so we have a single factor, multi-level, independent groups design. That's what we're doing. So here you can see the A1. These are people that do not play the PlayStation at all. They are playing it for 0 hours. These people play it for 1 hour. The A2 plays it for 2 hours. The A3 plays it for 3 hours. and the A4 plays it for 4 hours. So we're going to have these groups that are going to play the PlayStation, and then we're going to run them through our reaction time task. Okay, and then here is our data here for this example. Okay, so our null hypothesis, normally I would ask you guys this in class to respond to me. Our null hypothesis is going to be that there's no difference between our groups. We're not going to see any difference in reaction time, regardless of how much time they spend on the PlayStation. So we could notate this like this. All of our groups are going to be equal. So then we come up with our experimental or our H1, our alternative hypothesis, and we can do something like this. We think the reaction time is going to decrease with time spent on the PlayStation. We predict that people who play the PlayStation longer are going to have a better reaction time, a faster reaction time. So we could notate it something like this for our experimental hypothesis. So when we do this, how many tests will we need to perform? So we're going to compare this one to this one to this one to this one to this one, right? So A0 to 1, 2, 3, 4, and then A1 to 2, 3, 4, so on and so forth. So we end up with 10 different tests here for our t-test. So if we have 10 tests, here's all the tests that we would be doing, okay? So these are all of our tests. If we actually add all these up, 5% for all of these, we end up, if we have 10 tests and we multiply it by our 5% risk of committing a type 1 error, we end up that with a 50% chance that we are going to reject the null hypothesis when we shouldn't have. So we have a 50% chance that we are going to commit a type 1 error here. So it really inflates our type 1 error rate. So if we had 7 groups, that would bring us up to 21 tests, and then we would definitely be making a type 1 error. At least one of those tests is going to come up, and we are going to say that we're going to reject our null hypothesis. We're going to say, look, we found an effect. We're going to confirm our alternative hypothesis, and it is definitely going to be wrong. So we would end up with a 100% chance that we would be making a type 1 error. So this is why we don't do t-tests with more than 2 groups. So this brings us back to our single factor multi-level designs. We don't want to do a t-test because it increases our chance of making a type 1 error. So instead, we have this wonderful test to help us with this, known as the one-way analysis of variance. And again, the one way is for the one factor. So we have multiple levels. We're going to have at least 3 levels when we're doing this. When we run this test, if it tells us it's significant, okay, if we get significance here, then when we get the p is less than 0.05, that's whenever we know that we have significance, which is good. That means that we can feel comfortable rejecting our null hypothesis. It is supporting our alternative hypothesis. We are seeing a difference. When we get this test back, it's going to tell us that it's significant, but we don't know where the difference is. We're not going to know if the difference is between level 1 and 2, or between level 1 and 3, or between level 2 and 4. We're not going to know where this difference is. So we do have to do multiple tests. At that point, we can go in and we can do other tests to find out where our differences are between our levels, which level is different from which level. But it's important to note that we could only do this if we have significance, if our p-value is less than 0.05. If it is greater than 0.05, we cannot do any additional tests. It's dead in the water. We have no significance. We cannot reject our null hypothesis, so we cannot run additional tests on that data. We have to have significance before we can go and do some examination and figure out, before we can do some digging and figure out where our significance is. Okay, so there's a couple different ANOVAs that we could run. The worksheet is going to have you do one of each of these. So the first one is our one-way ANOVA for independent groups. This is when you have a between subjects design. So this is when you have an independent groups or an ex post facto. And then we have the one-way ANOVA for repeated measures. And this is whenever you have this connection between the groups, both of these. And so you would do this with a matched group or repeated measures. And honestly, this is like the way it's supposed to work because the matched group still has this like connection between them, but But really, because it really is between groups, the way you would actually run it in SPSS is you would have to run the one way for independent groups on that data, because it just doesn't work for repeated measures. Okay, so that's all I got for you guys today on this. I'm going to send the worksheet. The worksheet is very detailed. It tells you exactly how to do it. I will be on our chat in the morning. I will be available for office hours. I'm happy to meet with any of you guys anytime, and I can help you guys through this worksheet. This is a worksheet that we normally do as a lab together. We work it in class. We do it together. It is challenging. It is, it can be very challenging, okay? So I recognize that this working on your own might be a little tricky. So if you're feeling frustrated, if you're feeling like it's hard, it is hard, okay? But see if you can do it on your own. Reach out to me if you need to. And you guys are welcome to work with each other, work in your groups, find a friend in the class, talk about the worksheet. I'm open to that. Again, this is only for completion. I'm only going to look at it for completion. It's not for a grade, okay? I just want to make sure that you guys are doing it, you're thinking about it, you're giving it some effort, okay? And I'll give you feedback on those. And again, we'll talk about it together in class on Friday. Okay, thanks you guys. I hope you have a great rest of your day.